But I hope that you have been following online, have been following the recording session. The other, my colleague, because we spoke and we thought that it's better that we have one class online. Because when we start the student, I think anybody to join, right? So it's better that we have one class. That's what we are doing. But I hope that you do to attend and then look at the recording session. And I want to, our plan is that if we start the whole day chapter 3, I want to dedicate the first 20 minutes or 15 minutes to answer a question. I know that you have already a video session this morning and also show it. So if you have any question regarding chapter 1, 2, you are free to ask now. Just the first 20 minutes I want to use it to answer the question that you have regarding the testimony. Remember that we already covered chapter 1. Chapter 1 is after the Bible, chapter 2 is and then we start with chapter 3, which is set. Okay? And chapter 4 is the binomial theorem. Okay, so yeah. The test is not included in chapter 3. You are aware. The test is not included in chapter 3. So if you are preparing for the test tomorrow, just close your eye on chapter 3. But now, we are going to continue the lecture of chapter 3 today. So after I answer the question, I'm not saying you go outside. You should keep there. And yeah, now ask any question regarding chapter 1 and 2 that is bothering you, then we answer. If there is no question, then I assume that you are all ready for the test tomorrow, and then, yeah, I wish you good luck. Okay, please, yeah. Any question? Yeah, quick. Make sure that the question you're asking is a question that can be dealt with, yeah. Not for the whole class, for the whole class, because everybody needs to answer the question. It's not one-to-one question. Hold on. Increase your. Sorry? Come. Come and write your statement. Come, quick. We only have 20, maximum 20 minutes to deal with question. Yeah. So what's it? What do you mean? What is P? What is P? You don't say what is P. That question that you are asking, I don't know the answer. Because we don't say P and Q are any mathematical statements. Okay? So you wrote something. Where do you find it? Question D, which I hope is it what about the order? Are they following the same order or just jump? What is P and Q? Where did you get it? Okay. P and Q could be okay, any mathematical statement, any math statement. Okay? And you know, when you see P, when you see this symbol, it's in conjunction, right? It's N. Okay? Okay, so if I assume that P, let's assume that P and Q is true. Okay? Let me assume that P and Q is true. So for P and Q to be true, what does it mean? We know from the two table. If I do the two table, for me to have P and Q to be true, what should be the two table, the true value of P? For me to have P and Q to be true. Eh? So we need to have that P to be true. You guys, you are late. Eh? You know that the class is 45 plus 11. Huh? Yeah, just try to get time. And also, if you know that you are coming late, you won't just sit at the back. So and so you understand? So for this one, if you see P and Q, for you to have a P and Q to be true, that's something like that. P has to be true and Q has to be true. Both has to be true. Okay? So therefore, the argument P has to be true. Okay, so here now you need to write that P is true. You understand? From the two table already, from the two table. We deduce it from the two table. Okay? Yeah. Yeah. What's the question? Write that derivation. Yeah. Okay, okay. Let's look at it together. I want to find the negation of there exists x and x plus 1 given to n, right? Which one is it? The second or the first one? Okay. Okay, so that's what we want to negate this statement. Who can give me the answer? Okay, who can write the answer? The other is okay, that's what he wrote. That's what he wrote. You all agree with what he wrote. You want to negate this statement. There exists x and z integer. I think this there exists apply to there exists 3x in z. Okay? Oh yeah. Since if this should be the same thing, right? Because it's the same thing. And then x plus 1 belongs to n. So you say for all x in z, 3x is not in z, or x plus 1 is not in n. You are arguing? Okay. You haven't finished this one. Do you all agree with what he was saying? Huh? Who said yes? Okay, who said no? I want those who said no. Who disagree with what he said? Yeah, you disagree. Okay. Oh, can you come in correct? Okay. Interesting. Let's go. That's what you know before, and that's what you have now. Okay. Who else disagree? Who think that the first is true and or the second is true, or who disagree? No. Yes, who is speaking? Yeah. You agree with the second one? Which second one? Which second one? You mean this one? This one? This statement? This one? For all x. But okay. You say for all x, and then you have this one. Do you think that the whole statement is true? The whole writing is okay? Yeah. Why? End to all. Okay, so the thing is that we saw last time that if you have there exists, eh, when you want to negate, it becomes what? For all. Okay? So if you have there exists, and there exists, and then you negate some expression that have there exists, it becomes for all. Right? That's what we saw. And then if you want to negate a statement for all, it becomes there exists. Okay? That's what we saw. Now, looking at this statement, there exists means that at least one, at least we have x, we can speak one example that is in Z. And if we speak one example that is in Z, that simply means that 3x should be in Z, and x plus 1 should be also in, a natural integer, right? Okay. So another way, I could maybe write it like this. There exists x in Z, right? And then we have this 3x in Z and x plus 1 natural integer. Okay? You see the way that I wrote it? So actually, this there exists apply to this quantifier, x in Z. But after that, we still have another statement. Okay? So I will try to make it like this. Okay? Make it like this. You have there exists x in Z, 3x in Z, and x plus 1 in Z, in N. But we got, yeah. Sorry? This quantifier applied this. Yeah, it's applied this. Because if you manage to split, find one example, then this example that you see now, you could check that you multiply by 3. For instance, if I say there is this x in Z, and I take now 3, or maybe 4 is in Z. Now I need to check the other statement. 3 times 4 is what? 12 is in Z. And 3 plus over 4 plus 1 is in N. So you understand? So I give an example there. If I take, let's say there is X and so I pick X to be 2 for instance. So I just find out the then exists. Okay? Now I need to look at this statement. So we have now 3 times 2, which is in Z, and 2 plus 1, which is in N. Okay? Now, if we want to negate this statement, we need to negate this and also negate this. So therefore, when I'm negating this, the negation of this is what you wrote. You say for all x. Okay, the negation of this is for all x in Z. That's fine, yeah? But now, the other part, you have now what we call conjunction. The conjunction. We learn if you have P and Q. What's the negation of P and Q? Is it going to be right over there? What's happening? What's happening? Why people are going upside down? What? You don't say this yet. Okay, so P and Q, right? Okay, so what will that have? It will be not P or not. You see? You are negating the statement P and Q. So it will be what? Not P or not Q. Yes? You find the answer already now. Get the answer now. So what's the negation of this one? Huh? 3x or that's all. Okay? Do you understand the way that I did it? You see, it's clear now. Okay. Okay. So, who is asking about climate equality? I think we are just to let you go to the last question. Yeah. What? What's happening? You can see. Okay, come in front. Or you want to be a bit closer. That's because we need to move on here. But if you have any one-to-one question, you're free to see me. I'll be in office. I'm having another class from 1 to 2. After 3, I'll be available in my department between 7. Okay. Are you moving the attendances? Between 7. Second floor. Just ask students of the grades. Go to Mr. or the secretary. Okay. How does it make you are really going to business? How was the quiz anyway? It was easy, right? Okay. The quiz was easy. So I just hope that the test is also how that the test is also be easy because it looks like we are doing class and then people are moving outside. Okay. So what's the question? Use the track inequality and the fact that to show that What's the triangle inequality? So this statement just means that okay, what's the triangle inequality? We already we have seen the triangle inequality. A plus B is less equal to the absolute value of A plus the absolute value of B. I think that is what the very easy, right? Okay. So we want to use the triangle inequality in order to show that A minus B is greater than this. Okay? Yeah. But what have you done? What's your thought? Yeah, okay. Yeah, good. Yeah. Yeah. Yes, good. Mhm. Yeah, now you are kind of trend inequality for this one. Yeah. Yes. Yes. That's correct. That is it. You see now when you say look, this one now, this is a statement. You take this as A and this as maybe capital B. So you have now absolute value you have absolute value of A minus B, which is taken as one quantity plus now B. Now this A minus B is one value. B is one value. Now you apply the principle of equality, which says that the S is equal to absolute value of A minus B plus the absolute value of B. You see now that we know that this one is actually the absolute value of A. So this is equal to the absolute value of A minus B plus the absolute value of B, and then you get the answer. Okay? Perfect. Okay. So let's start the class of today. I hope that it's more or less clear. Why would I? You should be ready by tomorrow, right? So go watch exercise, go through the tutorial, and yeah, if you have a struggle, just you can work with pair, not with the test, but to your colleague, you discuss with them if you struggle, and then I'm just trying this exercise. Have you done this? And then you discuss. Okay, and I think you'll be ready by tomorrow. Okay. Yes? Okay. That's your first test for this year, right? That's the first test that you do right this year. Or you already wrote the test before. That's the first test. Okay? So good luck. Okay. Yeah. Okay, so we saw chapter 2 is about logic. We understand a bit of how to deal with math statements, negation, contrapositive, quantifier, all those that you have seen in chapter 2 will be useful for you in the future. And if you want to do math later, yeah, you will be using chapter 2 all along. Because, yeah, even chapter 3, because logic is actually, math is about logic. Yeah. My full life is math. I did math in undergraduate, master math, PhD math, you see. So I noticed that the whole period when I was doing all those years of mathematics, I noticed that I have been using logic all the time. Even now, I'm still proving some theorem. I have been using logic. So it's better to have a, if you know that your future you want to, do a career in mathematics, I know that it's the students of math here or media, even computer science, you be needed this logic. Yeah, you be needed. And so it's better. It's not only for the test. It's not only that I just need to learn it for to write the test. That's all. No, logic is needed and actually in the daily life. Okay. So yeah. So please, the basic understanding of chapter 2 is very important for future as well. And chapter 3 now is about set. So we want to actually understand what set is. Actually, set theory is a field of mathematics. Is a field of mathematics, a research field. That is a bit big, but we cannot say everything here. We will just give you an introduction of what set is. And set, we know that set is just a collection of elements. If I take some collection of elements, it can be considered as a set. That's a collection of families of elements. It can be considered as a set. So this class that we are now is a set. Because we have a collection of students. Okay? Yeah. So a set is actually a collection of elements. And it will be a collection of elements of the same nature. Because if you want to start understanding a set, you need to first of all look at the collection of elements that have the same nature. Okay? Yeah. So if an animal comes here now, I'm not so sure that we compare human beings as an animal. So we just don't look at the animal, but we see this as only students. So we can only be dealing with operation or understanding of self within the element of the that have the same nature. Okay, so and if you take a set, you can actually find a subset. Okay, a subset of the set. And if you find a subset, you can actually do some basic operations like conjunction, negation, complement. What else? There are few operations on a set that we can actually learn. Okay? Okay, so if I say A is a set, usually the set you usually write it capital letter. Capital letter. Whenever you are reading a math book and then set is using to do that as a capital letter. Okay? So A is a set. You see that natural integer N is a set of natural numbers. It's capital letter. You never see the natural number, a set of natural number written like that. Z, capital letter. Real number, capital letter. Okay? Complex number, capital. So sets usually use capital letter. Okay? And so the set that you are dealing with, it can be infinite or finite. You can have a set that is infinite or finite. I take an example. If you take the set of natural number, this is an infinite set. You cannot count. It's infinite. If you want to write down all the elements, you cannot write all the elements of n now. You can't. Because 1, 2, 3, 4, 5, it doesn't end somewhere. Okay? So it's infinite. The same way we have also what we call finite set. A set that is finite. I give an example of a set that is finite 2, 3, and 5. This is a finite set. And then the cardinality of the set is what the number of elements that is inside the set. That's what we call the cardinality. Okay? So what's the cardinality of this set? Is what? What's the cardinality of the set A? 3. Yes. So usually we denote the cardinality of A like this. Absolute value. When you see absolute value in some math, it just means that we actually value the cardinality. The number of elements that contain this set. If you assume that this set is finite. So the cardinality of A is what? Is 3. It's called cardinality. Okay? But the cardinality of n is infinite, the cardinality of n we cannot get is infinite. It's infinite. So sometimes we wrote it like this, but you could say it's infinite. Infinite. Okay? Okay, you follow here? You can stop anytime. Eh? So far, we are still written. Okay, now look. When should I say that a two set? If I take two sets, when should I say that a two set is they are the same? And let A be two sets. I claim that A equal to B when A equal to B. When A and B have the same element, what does it mean? If you look at the element of A and then you check the element of B, you realize that they have the same. But when we say element of a set, sometimes if you have a repetition, it can just be considered as the same element. I give an example. If I take my set as A, which is 2, 4, and 3. Actually, this set, 2, 4, 3. 2 is repeated, but it's just the same thing. It is the same thing. Right? So actually, I can write my set A as 2, 4, and 3. So actually, the cardinality of A is what? It's not 4, but it's 3. Because you realize that 2 is repeating, and 2 is the same element. So when you are counting element inside set, just notice that there is no, if you find an element that is repeating, you just take it as 1. If you look at my shadow now, if you want to count me, will you count me and then count my shadow? If you want to count me myself now, you will not count my shadow, but you are seeing me and then you are seeing my shadow going around. So that's the same thing. If you whenever you see a set, and then you have 2, 2, 2, 2, and then you have 3, 5, just see the 2, 2, 2, 2 that is repeated as one element. You understand? But if you see 2, and then later you see 2.1, 2 and 2.1 are not the same element. Yeah, it's different. So you count them differently. Okay? Yes. Okay. So now, if you say A and B have the same, they are the same. If I call it E, or when you go through the set, actually the set A can be written like this, and the set B can be written like this. So you just go through all the elements of A, go through all the elements of B, and you realize that every element of A is in B, and every element of B is in A. What does it mean? Mathematically, what does it mean? If you want to prove, if you want to show a statement A equal to B, where A and B are set, what you need to do is that you need to show that first, in step 1, you need to show that A is a subset of B. What does it mean? A is a subset of B. It means that for every element of A belongs to B. So that's certainly that, meaning that if you take let A belong to A, then B, A has to be in B, or maybe let me use X. That's the meaning. If I say that A is a subset of B, that simply means that if I pick an element in A, that element has to be in B. Okay? That's the meaning of inclusion. And then the step 2, I have to show that B is also a subset of A. Yeah? So that's something that if I take let X in B, then X has to be in A. And then at the end now you have proven that A equal to B. Yourself, yeah. Yeah. Oh, yeah, okay. Sorry. Yeah, thanks. Yeah. You take X in A, and then you show that this X is in B. Okay? Good. Any other question? So to show that I am equal to myself, I need to maybe, it's like you consider two distance of myself. And then I show that the first that I took is included to the other, and then the other included to the first one. And you show that they are actually one. That's the thing. Yeah. 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 Example. A, I take A, 2, 3, 4, and B as 2, 3, 4, 5, and 6. Actually, A here is a subset of B, right? Because every element of A here belongs to B. You take 2, 2 is in A, 2 is in B, 3 is in A, 3 is in B, 4 is in A, 4 is in B. So that means that every element of A belongs to B, but not all the elements of A belong to A. You see now? Okay. Okay, let's continue. Yeah. Yeah, perfect. Yeah. What's that? Step 1, A in B is a subset. A is a subset of B. Subset. 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 Am I correct? Right? At least I'm writing the right term of that. If you understand what my writing, that's all. Yeah. No, okay. Good question. The ordering. When we are dealing with set, the ordering doesn't matter. The ordering doesn't matter. Okay? The truth of the matter is that if I want to write the set A now, actually the set A is, I can write it as 3, 4, 2, 2. You see, I can write it as 3, 4, 2, 2. I can miss the order. It doesn't matter. If I'm taking this set now, the set of 3 then, wherever you see here today, next week you see it at the back. It doesn't matter your position, but I consider you as one element. That's all. I consider it as one element. So it doesn't matter the order. Okay? Yeah. It's not a subset. Yeah, what you say is not a subset, just yeah. Elements, an element is X in B, right? If you say A is not element, just make the difference between element and subset. They are not the same. Okay, so we have actually some few operations. We have a union, we have an intersection, we have different complement. So if you take a set AB, let A, B, two sets. Okay? A union B is actually the set of X such that X is in A or X is in B. Okay? That's the right. I want to characterize the set of A union B. So we know that A union B are the element that are in A or the element that are in B, right? Yes or no? Yeah? Okay, so A intersection with B is just X, the set of element X are any element, any arbitrary element. Eh? X in A and X is in B. Okay? Yeah? Now the difference. Sometimes if you say A, you could do like this. There are two notation or minus A minus B. Okay? There are two notation. A minus B is just the set of X, so that X is in A and X is not in B. So what are we saying? We are doing the difference of A by B. Okay? So we are taking the element of X, the element of A that are not in B. Eh? The element of A that are not in B. That's what we call the difference. Okay? We do one example so that you capture what I'm saying. We do one example. For all those operations that I'm writing, we do one example. Okay, and complement. So actually, when we start talking about complement, I could just I consider this set of students, but this set now I could do some partition. I could try to, have a subset, maybe the set of female and the set of male. Okay? But all those two sets, they belong to the same big set, right? Okay. Now, I will try to ask what is the complement of the set of female inside a big set of students here right now. Right? So whenever you want to you talk about complement, you need to have a big set. Like you have, this is my entire class. Okay? And I have this set A, and this is my entire class. So if I say I want to find the complement of A now, A has to be a subset of a certain big set. A should not be on its own. That's the limit. A should not be on its own. It should be a subset of a bigger set. Okay? So the complement of A now is what? The element that are in that big set that are not in A himself. That's what we call complement. Okay? So usually we wrote it like this. A complement. A is just the complement. So it's just the elements that is not in A. Do you understand all those operations? Because you begin in some second, then you're being asked, can you evaluate the union? Can you evaluate the intersection? Can you evaluate the difference? Can you evaluate the complement? Okay? Let's look at one example so that we understand what is going on. Okay? So let's look at this example. I consider my A to be 2, 4, 6, 8. I consider my B to be 1, 2, 3, 4, and 5. And I consider my universal set. Okay? My universal set here is the set of n integers such that 1 is less equal to n simply less than 10. And I want to evaluate what is A and B, what is A union B, what is B complement, what is A complement, what is a B complement, and what is B. I want to evaluate those ones. Okay? So actually, we start with, okay, so you see now, if you're writing the set, you need to close it. Eh? You need to close it. Don't do like me. Be aware. I need to close it. Again, you close it. So those two sets are both finite. And what is the cardinality of n? Yeah? What's the cardinality of n? I'm following. Yeah? What's the cardinality of n? What's the cardinality of our set A? 4. What's the cardinality of our set B? Cardinality. 5. Yeah, cardinality is just the number of elements, right? So those sets are both finite sets. Okay? That's the first thing you need to know about the set. Now, actually, those sets, they are actually a partition or a subset of another big set. So if I come here now, I start saying that what are the students, given students that have age less than 20? That I will say this is my set A. I say what are the main students that are age greater than 40? I put this somewhere over here. B. Okay, let's try to understand the set A and B. But actually, those set A and B, they are coming from a much bigger set, which is the set of students here. So that is what is U. U here is our universal set. So instead of integer, from 1 to 10, split with them. What does it mean? It's like saying n 1 less equal to n 6 less than 10. What does it mean? What are the elements of U? What are the elements of U? 1, 2, 3, 4, up to 9. Yes. Yes, up to 9. Because this is slightly less than 10. So it's up to 9. So I can you see now the way that I represent this set. I can go to take a set. A set have you can write it in different way. It has a different representation, but actually it's the same thing. So you see now that the first representation of this set. That's the first representation. Okay? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah? That is actually my set U. Yes or no? Okay. Am I allowed to include 0 in the set U? Why? Am I allowed? Why? Because it is required. Yeah, restriction. Yeah, good. So if you add 0, just simply that you actually you modify the set. This is not the same set initially. It's another set that you are doing. It's not our universal set. Okay? So the first representation is what we wrote. And the second representation, we wrote it in a discrete form. In a discrete form, we just listed. Discrete form means that you list all the elements now. Okay? But if you are living an infinite set, you cannot do like this because you cannot write all the elements of an infinite set. It's impossible. Can you write all the elements of Z? If you can write it, I can give you up to the end of the academic year. Okay? So let's try to find. Okay. All right. So let's try to do what is happening. So what do you say? We say we want to evaluate A and B. And we know what is A and the B. A and the B, if you want to write it in this one, you know that is the element that are in A and at the same time in B. That simply means the common. And the common, what do they have in common? A and B, they have what? And 2 and 4. Okay, so you see now A and B. A is what? Yeah? You see? Okay. Now, what is A union B? Huh? What is A union B? Huh? Don't be afraid. Just go ahead. What is A union B? You. Yes. 1, 2, 3, 4, 5, 6, and 8. Okay, good. Yeah, correct. Yeah. Actually, you take all of them together. And so A union B is what? 1, 2, 3, 4, 5, 6, and 8. Yeah. Do you understand? You understand it? Actually, A union is the element that are in A is the disjunction. When you say disjunction, you put them together. Eh? Disjunction. You have two things. You want to unite them, disjunct them. I'm not so sure if I'm saying the right word. You put them together. Okay? So the element of A is 2, 4, 6, 8. That's A. You put together with for the element of B. And that's the reset. Now, if you put them together, you will have some repetition. Like, I will try to do it like this. 2, 4, 6, 8, and then I put the B. 1, 2, 3, 4, 5, right? I can write it like this first. But actually, I can simplify this set because the 2 is repeating. The 2 can be considered as one element. 4 is repeating. Okay? What else is repeating? Yeah. And then we simplify the set like this. Because we said that if you have a set that have the same number, the same element, then just put 1. Consider 1. Okay. What now is a complement of B? Remember that B here is a subset. B is a subset of what? U, right? So if I want the complement of B, by definition, the complement is the element that are in the bigger set that is not in B. That's the complement, right? Yes or no? Yes or yes? Okay. Okay. So the complement of B is what? The complement of B at the back. At the back. Who is at the back? Okay. You looking at the back. Give me the answer. Yes, you. Yeah? I'm talking. Yes. What's the complement of B? Are you following? Are you sure? Yes. 6 at that time. Good. Yes. So 6. Yeah. The element of B is what? 6, 7. Huh? 6, 7, 9. We have 8 there. That's all. Because when you look at the set U, we already listed all the elements of U 1, 2, 3 up to 9. And so if you look, B here, that's our B. B start from here and then finish here. And then we are looking at the elements that are in U, that is not in B. That is what we call complement. The graphic picture is that if I have my A here, that is actually our complement. The complement is this one. It's not A, it's what is outside the A. Okay? Huh? Okay, do you understand? You understand? Okay, what is the complement of A? Yes, what's the complement of A? If you understand what we just say now, then what should be the complement of A? You don't understand? Yes. What's the complement? Yeah. What's the complement of A? 1, 3, 5, 7, 9. Good. 1, 3, 5, 7, 9. So the complement of A is 1, 3, 5, 7, 9. You take U and look at the element of A that are not in U. Okay? Now, let's try to find A and the B complement. A and the B complement. A and the B complement. You know that A and the B is still a subset of U and B. You know that? Huh? Yeah, okay. So, we already know what is A and the B. A and the B is what? Huh? 2 and 4. Huh? So, what is now the complement of A and the B? A and the B complement. It's clear. Okay. Now, let's try to find the difference between A and B. A and B, you write it like A. Sometimes we write it like this minus A. Okay? Difference. That doesn't mean that. Yeah? Sorry? Yeah. That 9. The 9 is in the U. The set U is the bigger set. 1, 2, 3, 4, 5, up to 9. So 9 is actually in U. That is not in A and the B. Okay?